Hey guys, and welcome to the Boyle's Law Lab. The Boyle's Law Lab goes with our gas law series. And if you guys remember from previously, the gas laws have four specific factors that we're studying and the relationship between them. Boyle's law specifically deals with the relationship between volume and pressure and how changing the volume directly affects pressure. So let's go ahead and get started. First, this is the lab sheet that we passed out during class. There is a front as well as a back, but since I have you here on this video, we can go through this quite a bit quicker. So when we start this lab, we needed a MacBook from our MacBook cart. We needed a Lab Pro receiver as well as the corresponding pressure sensor, and we need a 20 milliliter syringe. Now, the first thing we're going to do in this lab is we're going to push the syringe in to the 10 milliliter mark. We're going to go ahead and screw it in. You need it to be airtight, but don't over twist it into the pressure sensor. And then we're going to go ahead and start the program. Now, when you start the program, you're going to push your syringe in all the way to the 5 milliliter mark. Once you push it all the way into the 5 milliliter mark and you're holding it steady, you can go ahead and have your partner push the record button, which is this little wheel right up here. And what that's going to do is that's going to record the data points, 5 milliliters and the corresponding pressure, and it's going to put a dot on this chart. Now, after you've done that, you're going to go ahead and pull the syringe out to the 7.5 milliliter mark. And again, your partner is going to hit the record button. After you do that, you're going to go to the 10 milliliter mark, the 12.5 milliliter mark, the 15, the 17.5, and the 20 milliliter mark. Every time afterwards, your partner is going to hit the record button. When you've done all those different data recordings, you should end up with a nice graph that is a nice curve, just like this. The other thing that it's going to do for us is it's going to record all those points at which data was taken. And this is a really nice feature because it gives us an opportunity to go back and look at those data points. Now, I've went ahead and put them in a little graph for us so that we can see them just a little bit more clearly. Now, the one thing I want you to see on this graph is as the volume increases, pressure decreases. Okay? So as one goes up, the other goes down. These two things are working opposite of each other, and that's what we call an inverse relationship. Now, direct means they're doing the same thing. One goes up, the other goes up. One goes down, the other goes down. An inverse just means that they're doing the opposites. Again, volume to pressure is an inverse relationship. Now, anytime you have an inverse relationship, not just volume and pressure, but anytime you have an inverse relationship, you're going to have this nice curve like this. Okay? Now, one other thing that's pretty neat about an inverse relationship, if you take the two different variables that are inversely related to each other and you multiply them together, they are going to equal a constant. So, I've went ahead and multiplied these for us, and let's see if it works. So, here we go. Now, when I look at this, I can see that they're all very close. And there's a lot of environmental conditions that are affecting it, as well as it's not the most accurate testing equipment in the world. So, for all intents and purposes, this is actually a very good data collection. And this averages out to 950 milliliters kilopascal. Okay, so that would be our constant in this test that we're doing. Well, why is a constant important? It's important for several reasons. One of the big reasons is that we tested a very limited amount of points. Okay, we only went from 5 milliliters to 20. And so we just hit very specific points. But if we needed a more exact measurement, like what would it be at 8.5, I can now use the constant to solve for that. So let's take a look at how I could do that. Here's how we could apply this. What would the pressure be at a volume of 2.5 milliliters? Well, I didn't actually test 2.5 milliliters, but here's my constant, and I think I can use it to solve that. So let's look and see if it'll work. First, I would take the 950 milliliter kilopascals. Again, that's my constant. And since I multiplied the volume times the pressure to get the constant, what I'm going to do is I'm going to divide by my known volume, 2.5 milliliters. Now when I do this, milliliters cancels. I'm left with kilopascals, which are my unit of pressure, so that worked out correctly. And when I divide it, I end up with 380 kilopascals. That's excellent. Even though I didn't test 2.5 milliliters, I can see that is the pressure I would have if I had tested at that point. Well, it'll work the other way as well. What if I wanted to see what volume I would have to be at to get 40 kilopascals? I didn't test there. Well, I would start the same way. I would start with my 950 milliliter kilopascal constant, but this time I would divide by my 40 kilopascals. Kilopascals cancels. I'm left with milliliters, which is my unit of volume, so that's excellent. That's what I want to end with. And when I'm done, I've got 23.75 milliliters. So again, I have my data. I have the correct answer, even though I didn't test there. So this concludes my PowerPoint review of Boyle's lab, and hopefully it helps you as you go through the process of understanding gas laws. Not only the relationship between pressure and volume, but any inverse relationship that you come to. Thank you, and good luck with your studies.